A lot of material, and I appreciate the organizers having given me an extra 10 minutes. I have a lot of material to convey, and I would like you to focus your attention on my words, because these slides none of them are confidential. They're available to you freely. You can ask the organizers, you can email me, I will email you the slides. All the slides are based upon published peer-reviewed literature, wherever that is available. And if you have problems in actually accessing the publications themselves, because I know that sometimes it is difficult and expensive, I'm willing to also forward you the publications for your interest and research. So I was given this title, and what I'm going to do is, this talk is going to be divided into two parts. First of all, I will go over in some more detail, some of the principles of safety, quality, and efficacy, which were touched upon by Dr. von Borsdorf, and then I will look at these particularly important principles in relation to some of the major plasma products. If I can get the slides to move. What do I have to do to get the slides to move? Do I not press forward here? Yeah, I did, but nothing happened. All right, so this one. Okay, va bene. Thank you. All right. Okay, so I'm just going to go, as I said, over some important principles. And in fact, in relation to the safety of plasma products, the most important principle is really the safety from the transmission of pathogens, particularly the viruses which are borne by blood and which are found in certain frequencies in blood donors all over the world. The transmission has been the biggest problem in the history of plasma-derived therapeutics, and this has affected greatly the life expectancy and the quality of life of the communities of patients with rare diseases who are dependent on these therapies. I'm sorry that for some reason the font has transformed itself on this computer in a way which cannot be read which cannot be confined to the slide. But basically, advances in blood screening and donation has increased greatly the safety of normal standard blood transfusion, as is familiar to all of you. But with relation to the safety of plasma derivatives, we have to take into account some other features, because these are produced from very large pools of plasma, as has been emphasized by Dr. von Borsdorf, and they are given at very much rapid frequency in patients with chronic bleeding disorders such as hemophilia, patients with immunological deficiencies such as patients with PID, and so on. So the whole logistic, if you like, the whole framework of safety from pathogens for people taking plasma derivatives is entirely different, although it builds upon the framework for normal blood transfusion. Okay, now this is a slide which is extracted from the World Health Organization's global report on blood safety and availability, the very latest one, which is from 2021, and it shows what we all know in relation to everything else in the world, which is that blood safety is a function globally of how much money you've got. Wealthy countries in the high-income group can show a proportion of blood donors with positive reactions to these pathogens, which is much lower than the percentages which are seen in countries gradually with lower incomes. And this is directly a function of the amount of funding which is able to be put into the blood service in order to collect blood, select properly the donors, and test properly the blood. I shall talk about all these aspects. It is very important to reiterate what Dr. von Borsdorf has said, which is all these things require a investment and commitment. We like to use very much the word commitment in IPFA from the public health authorities to assure the safety of the blood supply. Now, this is a slide which is now quite old, and perhaps Dr. Ojmani later will update some of the data on this slide, but it shows two things. This is a slide which shows us the prevalence of the main blood-borne viruses in northern Indian blood donors in this instance, and the slide is a bit old. The data is stopping at 2014. And you can see two things from this slide. First of all, you can see, and we are happy to note this, a gradual improvement in relation to the percentage of positive donations, showing that in this particular blood center, the measures put into place to ensure that blood is safe were improving and working. And we can see, and I have underlined this, certain percentages in relation to the prevalence in the transfusion-transmitted viruses. And the point I want to make for you to understand is very simple. Those are very low percentages. They are very low in relation to the risk of having a blood transfusion. They are not low, and I will show you why, in relation to the manufacture of safe plasma products. We need to do much better in relation to plasma products to ensure that we do not get transmission. This, again, coming from this part of the world, shows that we still have problems in the subcontinent and adjacent countries, because this shows from a relatively recent outbreak of HIV in children in Pakistan that much of the HIV transmission was indeed coming, unfortunately, from contaminated blood. And this is from a publication in The Lancet, which, as I said, is available to you. And this is another publication from Pakistan. And again, I reiterate, and I have underlined the seropositivity percentages in the various transfusion-transmitted viruses. Again, these look like very small numbers, and in relation to standard blood transfusion, they are, although they are significant. But in relation to plasma derivatives, these are worrisome. And the reason is shown on this slide, and this is complicated, and I just refer you to the publication from which it is extracted. But the point which I seek to convey through this slide is that in this instance, this is a publication from the FDA, if an agent has a prevalence of 0.02%, okay, and from those previous slides which I showed you, there are some agents in blood supplies from this part of the world which have this prevalence, then this, in relation to plasma products, unless something else is done, and I emphasize, unless something else is done, will result in transmission. For sure, because of the prevalence and because of the high frequency of infusion. For example, a patient with hemophilia can expect to get a transfusion of factor VIII, well, in whichever form the factor VIII comes, up to 100 times each year. So this is important to reiterate. Now, many of these positivity rates in blood-borne viruses, Dr. Lenny has mentioned to you, are related also to the window period, the serological window period, which is not detectable through standard immunologically based tests, but which we have tests nowadays depending on the technology. And when I say depending on the technology, ladies and gentlemen, I come again to depending on how much money you can commit to the technology, which can shorten the window period and make the blood supply safer, but they can also make, and will also make, plasma derivatives safer. This is another interesting publication showing an attempt and a project in relation to an Indian blood bank in the introduction of NAT testing. And it is very important to note that as a result of this attempt at testing, and this publication is just about 2 years old, the safety of blood in this particular blood bank is greatly enhanced. But the important point is that this is not the case throughout the whole country, and it needs to be considered. As has been said by Dr. von Bosdorf, the most important contributor, the most important component to the so-called tripod for plasma product safety is pathogen reduction, and these have been the major advances in the blood system, in the plasma product system in the past 30 years. Reduction is the most important component, and these are just some pathogen inactivation methods, chemical methods, physical methods introduced deliberately, systematically, in order to have the aim of reducing the possibility that viruses which have broken through into the plasma, and I hope I have demonstrated to you that viruses will break through into the plasma, given the logistics of constructing plasma pools, that these are inactivated and removed. And the FDA has requirements for viral activation. Again, I apologize for the lack of clarity which the computer imposes on us, but the FDA, like all regulatory authorities globally, requires 2 of these inactivation or clearance steps. And this is because there are some viruses which are not inactivated chemically or physically through heating or solvent detergent method, as has been shown by Lenny, but which have to be removed using, for example, filtration and differences in the size between the viruses and the proteins of interest. It is important to note that in the past 20 years or so, many viruses have emerged out of the environment and into the blood supply, viruses which we wouldn't have thought about a quarter of a century ago, such as West Nile and dengue and other of these flaviviruses. These have contaminated normal blood transfusions and have infected recipients, but none, and I emphasize, none of these viruses have been transmitted by plasma products. And this is an enormous achievement of the plasma product industry, because considering that the plasma pools are made of tens of thousands of donors, and that, as I said, the recipients get exposed to the product continuously, it is absolutely no doubt that these viruses entered the pool, but the inactivation processes removed the risk. It's an important point. I will go over somewhat quickly of some of the points in more detail which Lenny put up in relation to the 3 components of the proper assessment of a product. First of all, we need to consider the quality of the raw material. This includes information, getting information on the regulatory status of the supplier, the donor epidemiology and the exclusion criteria, the screening tests done on the plasma, quality assurance measures, and so on. All these requirements are specified in the European Medicine Agency concept mentioned by Dr. von Bosdorf of the Plasma Master File. The Plasma Master File guideline of the EMA should be one of the Bibles of anybody wishing to embark on a plasma for fractionation program. Then we have the manufacturing process. I have already emphasized the need for viral activation and removal steps. We need to have process engineers to ensure that we have process consistency, and we have to have the ability to draw up the specification, the actual characterization of a batch of product to make sure that it has fitness for purpose. And in relation to the product itself, we need information on the product's potency, its shelf life, its expiry date. We need always to get the information on markets where the product is also available, and its clinical and manufacturing history. I am aware, ladies and gentlemen, that this country of Sri Lanka has recently had problems in relation to purchasing products which were counterfeited. These are problems which we've had all over the world, because mankind is wicked, as we can see in events happening in the world now, and we have people who are unscrupulous enough to sell products to countries which they think are vulnerable, which sometimes have no actual active ingredient inside them. Hence the need to have this principle absorbed in regulatory authorities, which need to be strengthened, which need to call upon laboratories under their own control to make sure that the product is what it says it is. And in the end of this particular piece of the talk, I remind you of the precautionary principle which is used in therapeutics evaluation worldwide, which is that where there is uncertainty as to the existence or extent of risk in human health, we need to take protective measures without having to wait until the consequences become fully apparent. This is an important principle. I will now talk about the products. Now, in this plasma industry, we have the concept of the plasma driver. The plasma driver, very simply, is the protein which determines how much plasma we need to collect. In other words, the protein which is in the greatest demand at that particular point in time. For many years, for decades, after the development of the process, albumin was the first plasma driver. For about 30 years after Edwin Coe had developed plasma for fractionation, albumin was what determined how much plasma needed to be collected to meet the market's demand. So let's talk a bit about albumin. This is a picture of the albumin molecule. I will simply summarize it by saying that for the purposes of the function of albumin in therapeutic products, we recognize 2 particular functions. One is the oncotic function, whereby albumin has the ability to retain water inside the circulation, maintain the circulatory volume, and therefore when we have people who lose this circulatory volume through injury, so-called shock, we are able to replace it by infusing albumin, drawing water from the extravascular circulation and restoring their blood pressure and their circulatory capacity. This is the traditional indication for albumin. Then there are what we call the non-oncotic or the pharmacological properties of albumin, and these draw upon much more sophisticated aspects of the molecule of albumin. We know that albumin is a very sophisticated molecule, and it has all these properties which you can see over there: transport, antioxidation, immunomodulation, anti-inflammation. These are important properties, and these are the properties of albumin which we have started to become very interested in the past 10 years. Very quickly, in relation to the traditional use of albumin in critical care, in treating volume loss through injury, we now have a lot of evidence that we can utilize much cheaper alternatives using the modern treatments of intensive care medicine and emergency medicine. We can treat many of the injuries and many of the problems previously treated with albumin with crystalloid solutions of various types. This is the Cochrane collaboration's most recent meta-analysis, which basically shows that comparing crystalloids to albumin in these circumstances results in a situation of therapeutic equivalence. In other words, crystalloids, which cost infinitely less, can give practically the same results. In relation to, and that was in relation therefore to the oncotic aspects, in relation to the pharmacological aspects, one area which has drawn great attention is in relation to patients who are suffering from severe sepsis, when the idea is that some of these properties of albumin, which come from the fine structure of the molecule, can be used to fight the infection, particularly the inflammatory response to sepsis in septic patients. This is a busy slide which summarizes the three large, pragmatic clinical studies done mostly in Europe and also in the Asia Pacific through Australia, New Zealand and other countries, which compare albumin to crystalloid. And although this is a very frustrating situation for those of us who are interested in this landscape, although we see improvements with albumin, this never reaches statistical significance, except in one trial which is shown in the black box in relation to patients with septic shock. So the jury in relation to sepsis and septic shock is still out, but it doesn't look as if we get the benefits which we expect on the basis of a lot of preclinical and molecular data to get. I'll comment about why this is in a second. This is therefore the guidelines of the Surviving Sepsis Campaign, in which they state, the latest guidelines, that for adults with sepsis or septic shock, they suggest using albumin in patients who receive large volumes of crystalloids over using crystalloids alone. But they emphasize that this is a weak recommendation with a moderate quality of evidence. Coming now to a very important and more recent utilization of albumin in relation to its non-oncotic properties, liver cirrhosis, again fighting certain aspects of inflammation and hypovolemia which occur in this condition, shown summarized in this slide. We again have controversial results. These are two separate studies. The one on my left is coming from the famous ANSWER trial conducted in Europe, published in The Lancet some years ago, which showed an unequivocal benefit in survival, in mortality decrease with patients with chronic infusion of albumin in cirrhosis, definite benefit. But another trial, also published widely in the New England Journal of Medicine, failed to show this benefit. So again, we have a situation where we retain equipoise, we just don't know what to believe. But it is important, I think, to understand why we get these controversial results. And some years ago, I conducted some research myself with a colleague from Italy, and we studied, mostly through the literature, but also some molecular studies, the possible effect of different solutions of albumin in relation to these effects which I have been talking about. And what we discovered was, and this is an important finding, that not all albumin solutions are the same. There is heterogeneity between albumin solutions depending on how they were manufactured, depending on how much they were stored, how long they were stored, temperature, and so on. This is just one set of data, which each of these data points shows a different albumin product, and it shows that there are heterogeneity within the albumin preparations. And this, I think, explains for us why we get different results in albumin in clinical trials. And so the lesson from this is we must always specify what type of albumin we use. We must study the albumin's molecular structure before we start pushing it into patients so that we can know that we have an intact functional albumin before we start the clinical study. This is an interesting, I think, study which was done in Indonesia. This is a cost-effectiveness analysis of utilizing albumin in this clinical scenario which I showed you before, the healthcare settings being the cirrhosis, the compensated cirrhosis. And the important point about this publication, which, as I said, is available if you want it, is that albumin is actually cost-effective in this instant. So if we have albumin which works, we can actually save money to the healthcare system by using it in these patients. I want to talk about the next driver. In the 1960s, with the discovery and exploitation of cryoprecipitate from fresh frozen plasma allowed the preparation of the first widely available concentrates of factor VIII, and this revolutionized greatly the treatment of hemophilia A. You can see on this slide some of the clinical manifestations of untreated hemophilia A in chronic hemarthrosis of the knee joint in this patient. This is a timeline which shows how things have gone on, particularly in our wealthy, privileged countries in the West. And we went through the era of plasma-derived concentrates, then we went through the first generation of recombinant concentrates, and now we have had, in the past 10 years, a virtual and wonderful explosion in alternative treatments, including the provision of gene therapy for hemophilia. But these are very, very expensive, and plasma-derived factor VIII remains a crucial modality, a crucial product for countries with emerging economies which can access through their blood system on the way to other products, cryoprecipitate, which can be manufactured and is a very good product if virally inactivated. This shows us the global factor VIII consumption to 2018 and the forecast for the next couple of years, and it shows that although there has been a decrease because of the use of the alternative biomolecules, we still have a great demand of plasma-derived factor VIII, and therefore this protein is of importance and of interest to you, I know. This shows us the role of providing treatment in hemophilia. This shows us the prevalence of hemophilia A relative to the factor VIII usage, and you can see that the prevalence goes up as you provide more and more factor VIII, and this is very natural and very easy to understand. The more factor VIII you provide, the more the boys survive and grow to adulthood, and therefore there are going to be more patients to count in the prevalence parameter. But also importantly to show that as we provide more factor VIII, the prevalence starts to plateau, because then we exit the zone of survival and enter the zone of quality of life. And as well as surviving, the patients now start to exhibit a higher level of quality of life. They can have jobs, the boys can go to school, and so on. And this is not always visible in prevalence. But it's very important to note that the more factor VIII we provide, the more we have quality of life in hemophilia. This is an important slide in relation to the role of plasma-derived factor VIII, because this is from the so-called CPIT study, which involved countries also in this region, in which plasma-derived factor VIII containing von Willebrand factor was compared in a randomized clinical trial to recombinant products and shown unequivocally that it resulted in a lower percentage of patients developing inhibitors. And this is immensely important because inhibitors are the most serious consequence of treatment today, now that the viral issues are part of history, and therefore I re-emphasize the relevance and the need to provide plasma-derived factor VIII. I want to make one point about cost, and this is to basically encourage you to think in terms of working together, because recombinant products are important, they are available, they are generally viewed as being more expensive, but in Australia, for example, where we have a national blood authority which has the power to construct tenders for the supply of the whole of our 25 million people in Australia, we are able to buy recombinant factor VIII cheaper than plasma-derived. Keep this in mind, work together, centralize your procurement processes, and you'd be surprised how much the prices go down. I just want to point out this little book which I wrote for the World Federation of Hemophilia. This is available for anybody to download for free. If you can't find it, I will simply send you a copy if you contact me. And it is a guide for the assessment of clotting factor concentrates, which summarizes most of the points which I've been talking about. I want to round off by talking about the current driver. Now that factor VIII in the wealthy economies from plasma has faded from importance, our plasma systems are basically immunoglobulin procurement systems. Immunoglobulin is very important, and immunoglobulin products have resulted in an enormous improvement in the survival and quality of life of people with congenital primary immune deficiencies. This two sets of data shows the situation for X-linked gamma globulinemia and also for common variable immune deficiency. And the point to be made is that as years have gone by, new birth cohorts have experienced better survival as a result of the ability to access immunoglobulin in concentrated solutions which can be administered intravenously. Another area of importance for immunoglobulin are the autoimmune neurological diseases. This is again an extract from the Cochrane Library, which basically shows that these have a strong level of evidence for their efficacy, but remembering always that other modalities such as plasma exchange and even corticosteroids have equal and equivalent efficacy effects. I will not go into that aspect in detail, perhaps during the discussion. I just want to go very quickly over the quality aspects of immunoglobulin. These are summarized in the European Pharmacopoeia's monograph on this subject. Again, Pharmacopoeia Europea is a very expensive document which anybody involved in plasma needs to have, and I'm afraid I cannot send you this because I don't have a personal copy. It costs thousands of dollars these days, but it is something which you need to invest in. It says that normal immunoglobulin for intravenous administration needs to be prepared from the pooled plasma of not fewer of 1,000 donors. Please keep that in mind in relation to what I said about the risk of viral infection, because immunoglobulin in previous eras has transmitted viruses. This is a slide which summarizes these episodes. Thankfully, thanks to having the kind of viral activation processes which you can see exemplified in these particular products, this is again public information, this is a problem of the past. But we must always remember this in order to maintain our caution and our standards. Other aspects of the quality of immunoglobulin include the need to ensure that there are no aggregates in the product. These can be easily detected using size exclusion chromatography, what we call HPLC, in the laboratory, because these aggregates, as you can see in this slide, result in high levels of complement activation. And you can see that the first generation of immunoglobulin products, which could be only administered intramuscularly, the highest curve on this slide consumes up to 90% of the complement, which shows that these are preparations which cannot be administered in large amounts. And it's a very important point to always remember. Another important point which came about to our consciousness about 15 years ago is that some immunoglobulin solutions have caused thrombosis. And this is just a slide showing some of the patient populations affected by this. And for this, the European Pharmacopoeia has also included the need to include a step in the manufacture, not just to remove viruses, but also to remove thrombosis-generating agents. Most of the thrombotic activity comes from contamination with blood coagulation factor 11. This is a slide showing one particular product. The different steps in manufacture are shown with the numbers there, and you can see on the right-hand part, as I look at this slide, that as the manufacturing process progresses, the amount of thrombotic activity in the product drops. And this is data which nowadays the regulators demand, quite justifiably, from every manufacturer. Another important concept which developed again in recent years has been the hemolysis of red cells of patients transfused with intravenous immunoglobulin. This comes about because of new manufacturing methods which give us higher yields in immunoglobulin, but which unfortunately leave higher levels of anti-A and anti-B hemolysis, antibodies which are very familiar to you as blood bankers. And so nowadays we need also to have a manufacturing step and measures to show that this risk has been decreased. And this is a slide which simply shows you how this has been done in one particular product. I will not go over this in detail because I'm conscious of time. I don't want to abuse the generosity of the organizers. Again, this is a little book written by me for one of the patient organizations which I advise, and all these aspects which I have talked about, including the quality of the plasma and the safety of immunoglobulin, are described in this book, freely available from the website of the organization or from myself if you have problems in accessing it. A couple of words on other important plasma products. Alpha-1 antitrypsin is important for patients who have a congenital deficiency in this protein. They get severe lung damage and liver damage from this illness, and some, although not all, of the disease is ameliorated through the use of a plasma concentrate. Very interestingly, prothrombin complex concentrate, a product which has been around for 60 years or so, was made nearly redundant because it was previously used to treat hemophilia B, but now has become much, much more important and economically valuable to companies which have it in relation to treating acquired bleeding disorders, reversing anticoagulants, and treating patients with massive transfusions. And then, of course, there is C1 esterase inhibitor, which is actually one of the most valuable proteins in the plasma in relation to its price, but which is used for relatively few people, and nowadays is severely threatened by the recombinant and other alternatives. So if I can approach a stop, if I can get to it from the difficulty in reading the slides, the plasma industry continues to grow, and it provides important medicines. It provides important medicines for people like myself, because I myself am a patient with hemophilia B, and for much of my life I depended on plasma concentrates. So it provides important medicines for small groups of rare disease patients. But these are people who deserve our treatment and our compassion as well. The evidence base for plasma proteins, as I have tried to outline in relation to albumin and immunoglobulin in particular, it ranges from the robust to the debatable, and chronic congenital deficiencies, again, have the highest level of evidence. As I have indicated, the industry's current driver is immunoglobulin, and the consumption is continuing to grow, and in our economies, we are focused strongly on making sure that not just the plasma supply continues to meet the demand for immunoglobulin, but that we manage this resource with the clinicians, with the patients better in order to ensure that treatment continues for everybody. I haven't gone much into the alternative treatments for many plasma therapies, with perhaps the exception of hemophilia, which I mentioned in relation to recombinants, but I would tell you that in relation to, for example, immunoglobulin, we are starting to see, very interestingly, the development of certain alternatives for some of the indications, and we view these as being a component in our capacity to manage the demand for this product and to therefore manage the way in which we manage blood systems. I believe that that is my last slide. I want to thank you again for your attention. I want to thank the organizers for the invitation, for allowing me to speak a bit more than my time. I realize I've been very fast But as I've said, the slides are yours to study if you wish, to contact us, both Lenny and myself, if you wish, and we are ready